So in this lecture, we're going to be looking at points of intersection, and this is quite a common exam question. So you might get a question like this, and I'm going to show you how you do it, and we'll go through this example together. So we're told triangle ABC has vertices A minus 4, 6, B 2, 0, and C 0, minus 2. Find the equation of the median BD, find the equation of the altitude CE, and then find the coordinates of the point of intersection of DB and CE. So we'll start off with the first question. So find the equation of median DB. So we can see here DB. And we should remember that for median, that's going to be halfway between the points of A and C on the line which is on. So first of all, we'll need the midpoint of A and C. So midpoint point D is equal to x coordinates minus 4 plus 0 over 2, y coordinates of 6 plus minus 2 all over 2, and that is equal to minus 2, 2. So that's our point D. Okay, so we now need to work out the gradient of the line DB. So MDB. So so x2, y2, and this is minus 2, 2. So x1, y1. So 0 minus 2 all over x2 is 2 and y2 is minus 2. So minus 2 equals 2 over 4, negative 2 over 4, and 2 minus 2 is the same as 2 plus 2. That simplifies down to minus 1 over 2. Right, and now we can work out the equation of the line. So it is just y minus b equals mx minus a. So y minus, we'll say 0, just take this point b, 0 is equal to negative 1 over 2 x minus 2. So y equals negative 1 over 2 x plus 1, because negative 2 times negative half just equals 1, and that is our final equation there. Okay, so next question. Find the equation of the altitude CE. It's this one here, CE, going to this point here, CE, which is a made up point. So what we're going to have to do here is figure out what line this line runs perpendicular to, get that gradient, then sub in the points that we know. Okay, so first off, we'll get the altitude of the gradient even of line AB, which is 6 minus 0 all over minus 4 minus 2, which is the same as 6 over minus 6, which is a gradient of negative 1. All right, so if we know that m1 times m2 is equal to negative 1, then this might seem a little confusing. If we know this is negative 1, what times negative 1 gives negative 1? It's 1. So you could flip it over, 1 over 1 is 1, change the sign is 1. So our new gradient, CE, is equal to 1. And then we can just sub this back into our equation. So y minus b equals mx minus a. And we know our point C lies on this line, so we're just going to sub that in. So y minus 2 equals 1x minus 0. So this is equal to y plus 2 equals x, which is the same as y equals x x minus 2. Okay, and that's the same, that's really simple, same question. And here for the slightly more tricky bit. So find the coordinates of the point of intersection BD and CE. So any kind of time you'll see this point of intersection is always going to be simultaneous equations. So we'll write out our two equations. So our first one was y equals minus x over 2 plus 1. And our second one was y equals x minus 2. And because here the y's, the equation are both just equal to y, you can just go straight to making these two equations equal to each other. So minus x over 2, sorry, plus 1, plus 1 is equal to x minus 2. And you can just simplify this. You can take this x over here, so it becomes minus 3 2x, and then take the 1 over there, so that's minus 3. Those minuses will just cancel. So then you're left with x is equal to 3 times 2 over 3, which is just this, and then the 3's will cancel. So your x is equal to 2. And because we were asked for the coordinates, we need to sub this x value back into the y value, y equation for y to get our final points. We'll sub it back to this one because it's nice and easy. So y equals 2 minus 2, so it's equal 0. So our point of intersection is 2, 0. And that's it. So what you're going to be looking for is solving the first two equations for where they are, and then making those two equations equal to each other, and then getting a value, either x or y, usually x, and then when you've got that, you sub that back into your one of these equations to give you your final coordinates.